Yeah.
Okay.
Some lineman hands.
Catch, dude.
Who said lineman can't catch?
Lineman hands.
You guys see that game last night? I love that Tony Dungy was the only person who thought Atlanta would win.
Tony Dundee, isn't that? Oh, I'm thinking.
He's a Super Bowl winning coach from the
I know.
Minneapolis
Colts, my favorite team. I was thinking of like
Wait,
their
did they
Edwards
win?
for a second.
Atlanta won, yeah.
Well, did ASU win?
Oh, I didn't watch any college football on Saturday.
Why son?
Actually, I did watch college football on Saturday. I don't remember what. I'm sorry?
Why son?
Y is sine, yes. For those who don't remember last week, magnitude cosine theta gives us x, and magnitude sine theta gives us y.
Wait, the magnitude? Wait, so is VI the magnitude?
Uh-huh.
Okay.
BY is the magnitude.
And it's always a good idea to kind of diagram it, because you're like, okay, 57 degrees is more up than out, so this is going to be my Vx, and this is going to be my Vy, and this is my V at 57 degrees. So I always recommend doing a little diagram to keep yourself on track. That way, if you accidentally put your cosine and sine in backwards, you can see it. And if your calculator is set in radicals, radical numbers, radians, and not degrees, you can be like, that doesn't number make any sense. So I always recommend doing a little diagram. That doesn't make any sense. Radians. 0.32, what? How did that be? Yes.
That bathroom thing's not gonna flop. I'm in here after breakfast and lunch, so I'm gonna be in trouble.
Looks like you're gonna have to
More
go
money,
to-
more problems.
Well, it would be less, yeah. It's more for. Because then
Works both ways.
Then he's gotta go to the bathroom and he can't afford it.
But it's for kids.
Dude, it's for kids with cancer,
It's for
Chris.
the children.
Kids with cancer. How come you hate kids?
Yeah, why do you hate?
Just want to go to the bathroom.
Stop making fun of them just because they're bald. Sounds like they had look funny.
I didn't say anything about their hair, bro.
When you just-
Okay, anyway.
Stop trying to make fun of their legs. Yeah, they can't even go at 100.
Those kids with cancer. Is that what this for? Is this for cancer reasons?
I have no clue what is it for.
Yeah. Anyway, who cares? All right. So Vx. What did you get for Vx?
16.3.
16.3 meters per second. Okay. So it's going up at 16.3 meters per second. And what did you get for Vy? Sorry, go over.
5.2.
Over. It's going over at 16.3 meters per second. And it's going up at how fast?
25.2.
25.2 meters per second, so it's going up at 25.2 meters per second. Hey, that's cool. So now we have numbers we can actually use. We have a Vx, which is going at 16.3 meters per second, and a Vy, which is going at 25.2 meters per second. And the projectile is going to go right through my math. Splat. All right, now, this is really, really, really important. Are you ready for this? What goes up, come down.
Must.
No, that's not
Must come down. What goes up, must come down.
You know, before I can.
So have you ever heard that before? Yeah, I know, I just made it up. I'm gonna patent it. I'm thinking about the Nobel Prize. What goes up, must come down. So here's the thing. If we ignore air resistance, it goes up for half the time and comes down for half the time. If we ignore air resistance, a projectile goes up for half the time and comes down for half the time. Make sense so far?
Yeah.
So we can basically say at the top, there's going to be a point called the apogee or the apex that we can label T1/2, or we can label it T-top. And T-top is going to be half the time of the overall flight. It's going to take half the time to go up and half the time to come down. Make sense so far? Yeah. If that is the case, is there some way that we can figure out how long it takes for the thing to stop moving in the vertical direction. It's never going to stop moving in the horizontal direction until it hits the ground. But is there a way that we can determine how long it takes for the projectile to get to the highest point?
You just multiply that by 2, it's half of the total time.
That is true. The total time is going to be, so yeah, down here, the t total will be 2 times the t top.
Yeah.
But is there a way we can figure out what t top is?
Quick maps.
You're getting there.
Oh, you're trying to give us a hint by throwing the ball or something.
Like every good mathematician will
Okay.
Gravity.
You know that gravity has what speed?
Negative.
So, yeah, so we know that the acceleration in the y direction, we also call it g, is negative 10 meters per second squared, which means if something falls for 1 second, with what speed does it fall after that 1 second? Negative 10. If something falls for 2 seconds, with what speed does it fall? Negative 20. If something falls for 3 seconds, with what speed does it fall? Negative 30. So far so good?
Yeah.
If you throw something up at 10 meters per second, how long does it take to stop? 1 second. If you throw something up at 20 meters per second, how long does it take to stop? 2 seconds. If you throw something up at 30 meters per second, how long does it take to stop? 3 seconds. If you throw something up at 25 meters per second, how long does it take to stop?
2.5.
Yep. 2.5 seconds. Does that make sense? So what did I use? I used Vy. I realized that it went up at 25 meters per second. That means gravity stopped it in 2.5 seconds.
Oh shoot.
Yep. So that means t top is 2.5 seconds and total time is 5 seconds. Ah, snap. Ah, snap. Scott.
So, I know we're kind of not talking about this, but like, what is the math that would go into like launching a rocket ship into space? Like, is that like?
Rocket
it's like,
science.
That's like
We
probably
will talk
really
about
advanced.
forces. So we'll talk about rocket science. We'll talk about forces. The thing, just a preview. Force is given by mass times acceleration. So the force that an engine produces divided by its mass gives the acceleration upward.
Oh, wow.
But here's the thing: rocket science happens special in that mass is dropping, so force is increasing. So the force is constantly getting bigger and bigger and bigger because the mass of the rocket is constantly getting smaller, smaller, smaller.
And then how does that?
Oh,
jet fuel.
Oh, the fuel's draining.
I mean, acceleration is constant. This is constant. Acceleration is going up. Yeah, exactly, because the fuel's you're leaving the fuel behind. But we'll talk about that when we talk to get to forces.
That must be a lot of
And then
fuel
it's-
to waste it down that much.
Yeah.
What's
It's like 95% of the mass of the rocket is about fuel.
What's the-
Wow.
So it's,
Wow.
well, the moon is really far away.
Well, yeah.
Yeah.
Sorry. Once they're in space, though, they
I
can
can
save
walk
like a lot of fuel because all they have to do is get the general direction they need to go, and then just
Yeah,
kind of
look at
like
the direction,
start
get a
it,
little
and
bit
then
of
it'll
force
just go on
and
forever, right?
And then you're
Mostly
cast
yes.
away.
Mostly yes.
Wait. I thought-
They need to make minute adjustments as they go because they themselves in the spacecraft
Oh, they have to
are
release
changing
stuff.
their momentum. Kind of like if you were just standing there and then suddenly someone if you farted, you'd move forward. Make sense?
Oh, I get it because like because they like push off walls and stuff
Yeah.
to get around
So
the cabin.
back to this. Okay,
Okay,
one
that's
question, then we'll go back to this. Okay.
It's sick.
There. No. Okay. So now we have the time to the top, which is cool, and we have the total time, which is really cool. So what can we do with this information? What's the next thing we can find now that we have the time to the top and the total time?
Okay, so now we just yeah.
Exactly. We can find distances. So do you want to do dy or dx first?
Yeah.
dx? Yes.
No,
Okay.
no,
So dx, because the horizontal velocity is constant, dx is just vx times t. And which t? Any t. Any t we want. So once we know what vx is, we can determine how far something is at any point in time. We can know how far it is at half the time, or the maximum range at 5 seconds. Or we can know how far it is at 4 seconds, or how far it is at 1 second. Well, let's go ahead and do dx max, which is called the range. So dx max is going to be vx times t total. And again, to emphasize, you can determine what the range is at any point in time. But if you don't go for the maximum range, we just use the total time in 5 seconds. And I don't care if you round up or down. We are determining how far yon projectile has gone after 5 seconds. Understanding we have 4 minutes left in class.
Wait, really?
Really?
Are you serious?
I'm totally serious.
Are you
We have
serious?
4 minutes left.
Time flies when you have fun.
Oh,
Okay.
absolutely.
Okay, so how far does it go? 81.5? Okay, I'm just going to go ahead and round that to 82 meters. So it goes 82 meters. How did you get that? For Vx, you plugged in 16.3, and for T, you plugged in 5 seconds.
Yes.
This is meters per second times seconds gives you 82 meters. Make sense?
To find the
Yeah.
V of y max, would you use V of y times t top?
Two ways to find Vy max. Okay. 2 ways to find Vy max. I'm going to give you the best way. You might hear a simpler way later on, but that simpler way only works for one specific instance. Here's how you find dy max, or dy, any dy. dy is vyt plus 1/2 at squared.
Oh, jeez.
This is the exact same formula we used for where something is in linear motion. It's dy equals vyt plus 1/2 at squared. Realize that a is negative. So, using this formula, how high did it go?
So would you use
Use the
T-top
T
though?
total or the?
Well, if you want to know how high it went, you would use the t-top.
Okay.
T-total should be 0, we would hope. We would hope T-total is 0. If T-total is not 0, then something has gone horribly wrong. But we would hope that T-total is 0. What we care about is T-top, because we want to know the maximum height, and maximum height is T-top. Yes, remember A is negative.
Got 31.75. What did you get, Chris?
Oh!
Uh,
Whoa, I forgot.
31.75.
That's what I got.
What? You got the same things?
Man, that must mean like big brain
So-
did it right.
Big brain together. And these numbers are just pure coincidences that the 25 and 2, no, these aren't actually coincidences, 25 and 2.5. But the fact that this one's close to that is coincidence. But anyway, so
It's gotta be
25 times 2.5 plus 1/2 times negative 10 times 2.5 squared. So how high did it get?
31.75.
Pretty high.
31, is this 38, 32? So about 32 meters.
Oh.
So it went whoop, 32 meters.
32 sat and
Yeah, because we want to know the maximum height. So the maximum height is going to be at the time top. Now, if you did time total 5 seconds, hopefully at 5 seconds you got 0. Hopefully. If you did it right, you can check your work. It's like, oh, did it right? Okay, 5 times it. Okay. Questions with the last 90 seconds of class?
Yeah.
Hey, Tally, could you press the button up there on the calculator or on the camera?
Oh, the silver?
Yeah, silver button.